The most important equations for understanding what's going on with chronic non-contagious disease in human beings over the age of 15 are known as Hamilton's forces of natural selection, which were published in 1966 in an article in the Journal of Theoretical Biology. Other people had thought about these forces before, but they never really done the mathematics. And this man, William Hamilton, perhaps the most important evolutionary biologist of the last third of the 20th century, in effect supplied us with the two key formal tools we need to understand what most people call aging and what people like myself now think of as the foundations of chronic disease. By chronic disease, I mean pretty major diseases: cancer, cardiovascular disease, metabolic disorders like diabetes, Alzheimer's, it goes on. So these are the things that the majority of the people who are listening to me right now are going to die of. Yeah, your ex-spouse could kill you with a firearm. You could wipe out on a highway or freeway through inattention, cell phone use, or intoxication, but most likely you will die of heart disease, cancer, Alzheimer's disease, kidney failure, liver failure, and so on, for reasons that are primarily not due to standard medical risks like bodily injury or infection. Now, these two forces of natural selection, published by Hamilton in 1966, come in two flavors. The first flavor, the first force of natural selection, is the force of natural selection that gives the impact of natural selection on your chance of dying. The second force of natural selection, published by Hamilton in 1966, is the force of natural selection which scales the impact of natural selection on your fecundity at each and every age. Now, there's a little trick here, and that is you don't have any fecundity before the onset of reproduction, so it's sort of like childhood gets a free pass on this one. It's after the end of childhood that that force of natural selection is observably important. So in Thesis 9, I'm basically saying, look, we're never going to sort this out if we insist on just telling verbal stories to each other, or for that matter, relying on metaphors. Metaphors are a wonderful starting place, but in science, and for that matter in medicine, they're not a great place to end up. You're better off ending up with some hardcore numbers. To get to the hardcore numbers, you have to use what we call formal tools, which means mathematics and computation. Or in other words, you might just say numbers. Keeping track of numbers, that's at the foundation of modern science. Both pencil and paper mathematics and computers are tools we use to do that with.